Hello everybody. Let me get this scale set so I get as much of the screen as I want here. Well, it's being stingy with me. So let me just go a little bit more this way. There. Now, I gave you this assignment yesterday, I knew it might be challenging, but you're up to challenge. I know that I think that you're brighter than you are, but I know you can figure things out. But all of us need practice figuring things out. Yeah, I didn't enjoy necessarily figuring things out at first, but once you get a little better at it, then it starts to be more fun. All right, so the key is knowing that you can do it if you just put your mind to it. All right, so let's look at this. So it says, will these ionic compounds precipitate when formed? Why is it important that they precipitate? Well, you know how when you pour two things together, if there's going to be a reaction, you need something to happen, right? You need bubbling, or you need a gas coming off or something. Well, with these ionic compounds, when you pour them together, what we're looking for to show the reaction is the precipitate. So formation of a precipitate is what shows, I'll abbreviate it PPT, shows a reaction occurred. All right. And I'll do an example of when one doesn't. All right. So a precipitate, remember, is just a product that does not dissolve in water. So since it's in a water solution, when it forms as a product, it can't dissolve. So what is it to do? It forms a cloud, or it looks like a snowstorm, or it looks like a blobs. They can be different colors. They're often white. And then because they're denser than the liquid solution, they drop to the bottom over time. The word precipitation is also used for rain, isn't it? And it's the same idea exactly, because the clouds are in the gas state of matter, right? And then precipitation, rain, is the liquid state of matter coming out of a gas, whereas precipitation of an ionic compound is a solid coming out of a liquid. All right, so it's just a new form of precipitation. So we saw over here that there are actually a whole lot of compounds that do not dissolve. All right, so not all ionic compounds dissolve. But when you look at the pattern, it's clear that, let's just look at sodium first. All right, let's look at sodium. And when you go down here, every single sodium compound dissolves. When we look at potassium, every single potassium compound dissolves. That's pretty amazing. All right, that's pretty amazing. Whereas there's really nobody else that's true of. Ammonium NH4 is also very soluble, isn't it? It's mostly soluble, so NH4. All right, now I'm going to have to quit using that because I'm losing my sickle. So this is sodium, and this was potassium. All right, I'll have to remember to use my mouse. All right, now let's look at this. I'll make it a little smaller. Let's look and see if there's solubilities. Look at this. Nitrate Every nitrate compound is soluble. Every one. Yes, every nitrate is soluble. All right, so that tells us a lot. So, in this first compound, sodium chloride is soluble, we would know, because it's a sodium compound. Silver nitrate must be soluble because all nitrates are soluble. All right? So similarly over here, we would know that this must be soluble because it has both sodium and nitrate. And then over here, well, we don't know about silver chloride. So when we go over and look at silver compounds, let's find silver. Here it is. Silver compounds. Many of them are insoluble. And who with? Well, gee, fluoride? No, okay with fluoride. Chloride? Bromide? Iodide? It's not soluble in carbonates, all right, or phosphates. We'll ignore the nitrites only because we don't have any. I don't have any solutions of nitrite. All right, so we've seen some general patterns now, haven't we, in this chart? All right, so let's go over here now and talk about these reactions. So you were supposed to figure out these reactions as well. All right, KOH, we know this is soluble because all potassium compounds are soluble. And so what would be in it? Well, potassium compounds, remember these ionize? And the polyatomic ions stay together. All right. So KOH, remember when we were doing these reactions? All right, it would form one K plus an OH minus. And these would all be in water solution, aqueous, dissolved. All right. And then iron is a +3. But when it ionizes, it forms an iron +3 plus 3 chloride ions. All right. So remember, this is the previous lesson. So we'd have one here, one here, one here. All right. So that's filled with solutions. So when we pour these together, the question is, what will happen? Well, we'll have all those ions will be dumped in this container. All right. So every ion we have here will just be dumped into this container. All right. With double the volume. So that's why I made this double wide beaker. So we will have potassium and hydroxide swimming around iron and chloride. But when iron and hydroxide get together, and we go over and look at that, we discover, well, iron hydroxide isn't soluble. Have we lost our little, there it is. Let's find iron. Here's iron. All right, let's go find hydroxide. Here's hydroxide. All right. So iron hydroxide is insoluble. We're up here with iron. We come down and then go across to hydroxide. So that would be a precipitate. All right. So this would stay together. It doesn't ionize. All right, and it would drop to the bottom because it's a solid. And then the other guy would be KCl. Well, all potassium compounds dissolve, and because they dissolve and they're ionic compounds, they would just be ions floating around in solution. So what drives this reaction to continue is we keep pulling out the product of iron hydroxide, and more of it sits on the bottom of the container until there's no more iron ions, no more hydroxide ions. So what keeps this reaction going is the formation of the precipitates. All right, now could you do that on your own? So now we're applying what we have learned in the previous lessons. All right, so put who would be in the beaker, remembering that barium is bonded with a polyatomic ion. All right. And so the barium ions would be in solution. And then the whole polyatomic ion would be in solution. And we need two of them because nitrate is only a -1. So when you have an ionic compound that dissolves, then you automatically get the ions, one barium ion plus 2 plus 2NO, 3 minus 1 ions dissolved. All right. In this beaker, there's Na2SO4. Well, we know this dissolves because of sodium compounds. So these would all form ions. All right. So these would all form ions. So we'd have 2 sodium ions. All right. Plus 1. And then we'd have 1 sulfate ion minus 2. And these polyatomic ions don't break apart in water. The polyatomic ion stays together. All right. Now, let's see what would happen. So if we exchange dancing partners, that means barium would now be dancing with sulfate. And sodium would now be dancing with nitrate. All right, -1, +1, +2, -2. See how these charges are the means of getting correct formulas all the time. All right, now we go and look. We know all sodium compounds are soluble, so that's going to clearly be soluble, and we'll have Na plus ions in solution and NO3 ions ionizing. All right. But what about barium sulfate? If this reaction is going to go, barium sulfate has to be a solid. Is it? Is barium sulfate a solid? Let's go see. Barium, here it is. Barium sulfate. Here we are at the bottom going across. Sulfate all the way across here. Barium insoluble. So barium sulfate does not dissolve. It does not dissolve. All right, so we'd have BaSO4 forming. It would not break into ions because it is a solid and it would sink to the bottom of the solution. All right, the solid won't form ions. All right, so then we have sodium and nitrate ions around doing nothing because they're just soluble. But barium sulfate forms a solid that precipitates out because it doesn't dissolve. So the solid hasn't dissolved. All right, and that's the key here. Now, sodium hydroxide and silver nitrate. All nitrate compounds, all compounds with nitrate in are soluble, all sodium. So we know these are going to be two clear solutions that we pour together. All right, and so we have water in our containers, water in this container. All right, so with NaOH, we know they're both soluble, so I'd have Na plus, OH minus. Silver nitrate, soluble, Ag plus, and O3 minus. All right. So when we pour these together, all these ions are present. But when silver and hydroxide get together, we have AgOH. And when sodium and nitrate get together, we have NO3. Oh, that would definitely be soluble, wouldn't it? But let's go see about silver. Let's go check on silver oxide. What is its story? All right, here's silver. Silver hydroxide. Here it is. Very slightly soluble. So it won't appear quite so fast, but most of it is not going to dissolve. All right, so when this AgOH forms, it's a solid that drops to the bottom. All right, whereas this is just still dissolved. It's aqueous. So all of these dissolved in water, aqueous. Aqueous we pour together. But now we have a solid, AgOH. So it's not aqueous, it's a solid, isn't it? All right. So this is bringing us up to the lab we're going to do, in which you design 5 experiments that are going to work. That is 5 reactions that will occur when you pour 2 clear solutions together. All right. Well, that's it for now. So I'll talk to you later. Bye.